Okay, so here we go again. Let's look at another finding the linear regression problem. So this example here is, once again, it's just for another practice for all of us here. So the first example I showed you, you already got a good taste of that. So now let's try it all again, and hopefully after this second example, you are going to get better in the sense of computing the correlations, coefficient in the sense of computing the slope, and then computing the y-intercept, and get a better understanding of what the linear regression is all about. And also, hopefully after this example, you are also going to get better in terms of graphing the line. Okay, so once again, here we go. This is our data set. The data set this time is somehow larger than the other one. Okay, once again, you can spend a couple minutes writing this data set down, or you can also once again refer it back to some of the example that this is the data that we were using for some of the examples, for one of the examples, finding the correlation coefficient. So you can always look back into your notes and rewrite that on this data and copy this data. But anyway, so the goal here, right? We want to complete the equation. We want to complete the equation capital Y of M capital X plus B. Right? And once again, I have already given you the formula how to find M. I have given you the formula how to find B. So this time I am not going to give the formula again. I'm going to go straight into computing it. So, and once again, we do need to know the correlation coefficient. And so once again, once again, we must go back to some of the example that we found, that we computed the correlation coefficient for this particular data set right here. And so I can see that if I look back and reuse the information from the example that we found the correlation coefficient for this problem, then my R value is going to be negative 0.95. That's my R value. Okay? And also, if I look back at the example of finding the correlation coefficient, I also learned that my standard deviation for X is 3.04. The standard deviation for Y is 3.15. Okay? And I also learned from the example finding the correlation coefficient is that X bar, which is the mean for all the X for this data, is 5.29. 5.29. And I also learned that the Y bar, which is the mean value for all these Y values there, is a 5.43. Excuse me, 5.43. Okay, so this time, hopefully the example can become a little more quickly. So now, to find M, I'm going to just throw it into the formula. M equals R times Sy over Sx. And then I know all the information just now. So my R is minus 0.95. So I keep it there and multiply that to the fraction. And my fraction here would have 3.15 on top as a numerator, divided by 3.04 in the denominator. And that's how I find my M. So my calculation is going to show so 0.95 times 3.15 divided by 3.04. Okay. My calculation shows that the M value is a negative 0.98 approximately. Okay. So I have found the M value. That's one step. Okay. In the next step, I need to find the B value. Okay. Because in my equation, once again, in the equations, really the whole point of this equation here is we only need to find out what M is and what B is, and we're good. We should, as long as we find out what M and what B is, we can find out, we can go ahead and graph the line. Okay, so now my b value is going to be y bar, which is the mean value for all the y values, minus the slope that we found earlier times the x bar. So that is indeed, I have a 5.43 minus, and then the m that we found is negative 0.98, and times with 5.29. This is my x bar right there. This is my m that I have just found, and this is my y bar. That's my minus sign. So now my calculation will show it's going to be 10.61. So this is my value for the b. Okay. So now, my equation would indeed look like this. So the equation for the linear, so the equation is y equals to minus 0.98 x plus 10.61. Okay. So that is the equation for the linear regressions, the equation for the best fit line. And you are going to use this equation right here, you are going to use that equation here to graph. Okay, so once again, we are going to look at how we can graph that together with the data point. So now, for simplicity, I have already, beforehand, I have already plotted our data point here. So these are the data points. These are our data points for this data set right here on the graph. So this is how it look like. Okay, and so now, and you can kind of see that all the points here, they don't really line up on a line, but then these points right here, they're all together. It seems like they're all dropping down, right? So this is my example 2. Okay, the equation y equals minus 0.98x plus 10.61. So now, to graph, and once again, to graph a line like this, to graph a linear equation, all you do is you always start with the y-intercept. You always want to start with the y-intercept. Okay? You always want to start with the y-intercept. Now this time the y-intercept is a 10.61. So you're, on your y-axis, which is the straight vertical one right here, on your y-axis, 10.61 will be about 2, 4, 6, 8, 10, and 10.61 is about somewhere. This time I'm going to make it better seeing for you, I'm going to graph the line in red so that you can see what's going on. Okay, so 10.61, 2, 4, 6, 8, 10, and 10.61 is about a point there. Now this point I'm putting right there is just a point. The point in red that I put right here is the point for the graph, for the line. It's the point to help me, draw the line, but it's not the point it's not one of our data point. Okay? And so now my next point here, because when you draw a line you always need 2 points. So now my next point here, you would need to rely on the slope that we have found already. So now starting with this first point here at the intercept, you're going to count over to the right 1 unit. And then you're going to count down minus, because it's a minus right here, so you're going to count down. So it's going to be this point right here, you're going to minus. So it's almost 1. So it's this line, this point right here. That's my second point to draw the graph. Okay, so now I'm going to connect the 2 points, the 2 red points here. I am going to connect my 2 red points. Okay, and you can kind of, so far, you can kind of see already on the screen already that my ruler It's giving me a line, and this red line is not now. It's not exactly contained on the data point which is being plotted in black here. It's the red line is not exactly containing the data points. However, the line here, the red line here, is the line that you can see that it's very close to all the points here together. It's like the closest line, it's like the line closest to all these points together. Okay, so this is the line, that line right there in red, is the line y equals minus 0.98x plus 10.61. Okay, and this drill right here, this kind of, and in this problem, you can see that since the slope itself is a negative slope, so the line here is dropping down, and it's also consistent with the fact that all our data points right here are dropping. Okay, so this is the end of our discussions on linear regression.